All right, good morning and happy Monday. I'm planning on doing the LeetCode daily problem for today, March 27th. So here we go. Problems, March 27th. And okay, cool. This looks like an oldie but a goodie. Okay, move down and right. So we can recursively do this top down and then bottom up, top down. All right, so we'll take the best of above and to the left. Or right, yeah, above and to the left. And go down into the right. Yeah, the best of down and to the right as we recursively go. And then as the recursive stack unwinds, then we'll choose the optimal. Mn is the amount of rows, the amount of columns in the grid. Okay. Tab goes I0, J0. Return the best solution as we go. If I is equal to M or J equals N, and we'll return infinity. Maybe we don't want to go there. Went too far. I suppose we can simplify this too if we don't want to recursively go to M or N. If I is equal to M minus 1, J is equal to N minus 1, then return A sub M minus, or IJ, right? There's our base case when we get to the target goal, the bottom right from the top left. And then left, or actually down will be, oops, go I plus 1 J, left or right, equal go I J plus 1. So return A sub I sub J plus the minimum down and to the right. Turn go. Then we can minimize this thing. And yeah, as the recursive stack unwinds, then we'll accumulate the best down and to the right. Okay, that looks good. 12 and 7. Okay, cool. Then we'll add a memo. It should be accepted. Let's see, I saw this about 2 years ago. Yep, okay, cool. So that's top down. It took 6:42, 3 minutes for the top down implementation in Python 3, which is accepted. Yay. Okay, then we can do this bottom up. All right. DPBR memo explicitly created from the bottom up. So we can fill it with infinity and then go from the bottom right to the top left. So Python 3 is kind of strange in that we read it from right to left sometimes. This is one of those cases where we read it from right to left. So for each of the rows from 0 to M inclusive, we create the column for the entry. And this is basically explicitly our memo. And we'll mimic the recursive stack unwinding from the bottom right to the top left and then return to the top left. So for in reversed range 0 to M inclusive or JN reversed range index 1. for 0 to n inclusive. Actually, we don't want to go all the way. Right, we want to go from here, and then we'll consider down to the right for each of these guys. Yeah, so if we start at m minus 1, n minus 1, actually, how do we want to, we have to explicitly set up the base cases. Right, so basically the same code that we had before, right? So if I is equal to n minus 1 and j equals n minus 1, oops, and dp sub I sub j is equal to a sub I sub j, right? That's our base case. Otherwise, down or to the right is infinity, then we don't want to add that part. Minimum up, down, and to the right, right? Okay, yeah, so otherwise, dp sub I sub j is equal to a sub I sub j plus the minimum up, down, and to the right. Down would be dp, oops, down equal to dp sub I plus 1 sub j. Right is dp sub I sub j plus 1. Yeah, we can clean this up a little bit, but that looks right, I think. Here's our base case and our recurrence relation. Yeah, that looks good. Okay, cool. 642. Nice. Okay, cool. 642. Oops. To 646. About 4 minutes. Bottom up. Right, implementation, Python 3, which is accepted as well. Yay. And the current row is only dependent on the previous row, so we should be able to do some memory optimization as well. So let's call this thing previous. Oops. So previous row, 0. Row we built upon previous row. Should be okay. Previous equals current here at the end. And then basically for each current, so I, we build it from a previous I plus 1. Okay, that was good. Nice, okay. The memory optimization seems legit. Nice, okay, cool. 2 minutes from memory optimization. It is from of square and quadratic memory to O of n memory. Placing dp sub I with current dp sub I plus 1 with previous. Right, okay, cool. All right, that's all she wrote. Get you all next time.